Hi there, my name is Joel, and for the Chainlink Virtual Hackathon, what I wanted to do was build something with the Tezos blockchain. I thought that they were a sponsor of the platform, and I really like their technology. So I wanted to build something with the Tezos technology and blockchain. And what I've built is something I'm calling Tezos Sign, which is essentially a way to validate documents and put them onto the Tezos blockchain so that at any point in the future you can go back and validate the integrity of a document when it was created, the author of that document, any notes that you might want to assign with that document as well. Um, Really, the thoughts behind this came from kind of the struggles that I've seen when it comes to copyright law, intellectual protections law, and just general ownership of documents where you want to prove that, yes, I've done something with this document. It was at this time. I have the rights for this. And right now, there's really no secure way of doing that. And I know some people have tried to do it on the blockchain, and I thought that doing it with Tezos would be a really, really good option. And I'm grateful for the opportunity to try to do that during this hackathon. Um, and so with Tezos Sign, basically what you can do is you can go ahead, upload a document, we'll hash that, and then place that hash along with some other metadata onto the Tezos blockchain, and then allow an interface, a web interface, to go in and pull out some of that information so you can validate a document as well. You can record your name, time, and then also any other notes that you might want to record along with that document that will also be part of the blockchain as well. And then, of course, a really big piece of this is the ability to validate those documents as well. So at any point in the future, if you want to come back, you can easily upload that same document and then see if there's a match in the blockchain. So we actually use PyTezos in that point to actually go back, scan the blockchain, see if there's any records for that document hash, and if there are, we'll actually pull that out and show that to the user. We're also using SmartPy, which is a really nice piece of technology that allows us to use a few different abstraction layers above the Tezos chain. So basically, we use SmartPy to use Python to create some smart ML contracts. Those get compiled down to OCaml smart contracts, which then get compiled down and then put onto the Tezos blockchain. So there's a few different iteration steps there, but SmartPy was a really, really important piece of technology for me, and I found that it really made the development of this to be much, much easier than if I had to do it another way. And then another thing that I found was I needed kind of a proxy between the smart contracts and then my web front end. So I actually ended up using Chalice, which is a serverless framework to kind of create a serverless function that receives API calls from my front end, uses SmartPy and kind of these other Python tools in the cloud, and then interacts with the actual blockchain and the smart contracts as well. So if you take a look in the structure of the GitHub, which I've posted, so you can see that Tezos API is that serverless layer. Tezos Web is that web layer, and I have a demo of that in just one moment I'll show you as well. And then contracts are the actual SmartPy contracts, which I'll also show you in a second as well. And if you'd like to run those locally, here are some basic steps. Again, head to my GitHub, pull down the code, and then use a few of these steps just to go ahead and run it on your own here. But so with that, without further ado, let me jump into kind of a demonstration of Tezos Sign, and then I'll go into the smart contracts behind it and what that looks like. So this is admittedly a pretty plain user interface, but it gets the job done. On the left-hand side, we have the ability to upload a new document, and then on the right-hand side, we have the ability to go back at any point in the future and validate an existing document against what we have on the blockchain. So here, I'm going to go ahead and I have the opportunity to drag and drop or upload a new file. I'll go ahead and select, in this case, a closing disclosure, which is often used in real estate. So this is a nice example of a document that's very important. You wouldn't want it to get lost, and you wouldn't want any arguments over the correct version, because generally with closing disclosures, there is a lot of iteration going back and forth, updating particular fields. So in this case, you can see that, yes, I went ahead, I uploaded this into the system. It is now saved on the blockchain, the name of the document, the hash of the document, the size of it, along with the time. That's all saved, that's placed onto the blockchain. And if I'd like to go back and at any point, validate that, I can hit the validation button here, select that same document, give that a second, and you can see, yes, there is a match. This is the name of the document. This is the size in bytes. and then this is when it was uploaded. So you can see the preliminary of what we're trying to accomplish here, which is we have a subset of data about this document, we've stored it, and if in any amount of time, in any amount of years, someone wants to verify the integrity of this document and who actually uploaded it and all this information, you can come back here and actually validate that. So that's the demonstration. Let's quickly finish this off by jumping into kind of the SmartPy contracts. And SmartPy, they're really nice in that they have kind of a web environment where you can actually write these, and then they have some of the compilation happen right in your browser. So this is a really nice way of developing and debugging kind of the smart contracts. So a little bit on the left-hand side, you can see we're defining the Tezos Sign contract here, and then we're also defining the multiple entry points that we can have with the contract as well. So of course, probably the most important one is the ability to register that document, right? And so we're gonna, this entry point will register the document, it'll take the hash of that document, and then it will go ahead and store that on the blockchain as well. So this is of course the entry point where you can register the hash. You can see it stores the timestamp, the name, and of course you could really expand this to a whole bunch of other information if you wanted, the authors, multiple authors, for example, a whole subset of information that you might want. And then of course the second document entry point here is the validate doc. So on this endpoint, this is where you can provide, again, a hash of a document. We'll go back, we'll actually, what this does, which is very interesting, is it looks back at the previous hashes and then it updates the last doc entry on the blockchain with the value of that, with the information, the meta information for that document. And then what happens is we use Tezos to go back, look at the blockchain, and pull out the value for the last doc. So hopefully that makes a little more sense. We'll take a look on the right-hand side, and I think this will make a little more sense. So on the left-hand side, you can see we have a hash to doc, right? So this is where you take that document, you hash it, and then this is what you end up storing on the blockchain. So you can see the key created by, again, we could expand that to have other information. And then when you hit validate doc, what the logic does here is it goes back, finds that information out of the hash, and then places that in the last doc. So it basically does the find for you. And then again, we use Tezos to go back, look at the blockchain, pull out that information from the last doc field, and that is what's actually produced here on the front end. So we have a bit of back and forth there, going to the blockchain and then afterwards pulling the information out. But again, so this is the SmartPy editor. You can see this is the contract we've written, and then also the test on the bottom as well. That's generating this. So just a few comments on this. This was a really nice tool to use. This did make it a lot easier. Usually when I work with smart contracts, it's very difficult to debug when it's on the blockchain. And so this tool was actually very helpful in just getting through the code, and when there were issues, figuring out what was going on and really getting to the end of it. I don't know if I really could have done it without this tool. I'm sure I could have. It would have taken a little bit more time. But that being said, thank you for watching. I appreciate your time. Really look forward to your comments on this. I look forward to actually building on it a little bit. I didn't get, within the time allotted, I didn't get to the final version I really wanted. I wanted to really add a full rich data set behind each document. I ended up just kind of putting time and author and notes and stuff like that. But I'd love to build this out in a more formal way. But looking forward to your comments as well. I appreciate your time today in watching this, and thank you very much, and have a great rest of your day. Thank you.